Hello community! Today we have 5 RAG notebooks, Python notebooks that we will look at. And we will look at RAG, we look at function calling, we look at here the Llama indexing, or maybe a Haystack library. We will build a RAG system from scratch in our notebooks. We will build a notebook that will use a ReAct agent, and we will use here the Mistral LLM. Plus we have the option to build it either in a cloud-based or in a local Ollama implementation. So let's start with our first notebook. Now you ask, hey, how can we generate our embeddings ourselves? Notebook number 1, here's it, it's beautiful. So whatever are your text chunks, we generate here the embeddings in a vector space. How we do this? Now, some easy steps. We generate here the text embeddings, so we produce a vectorial representation of pieces of text, what we call embeddings, that encapsulate the semantic essence of an input text within a high-dimensional vector space. Then we have here a distant measure between the embeddings, so we quantify the semantic similarity between the text by measuring here the distance by the corresponding embeddings. We have a paraphrase detection, we have an efficiency for batch processing, and we will have a visualization. We want to see where are our vectors in a 3-dimensional space, and therefore we have here a dimensionality reduction, and we go with the most simple T-snare mechanism. Then we will use here the text embedding as features in machine learning models for classification task, or if you like, you can have a clustering of your data, and of course, we leverage here the embeddings for information retrieval and augmentation in generated brand new responses to the user query. Or maybe you're interested in notebook number 2, where we have a look at function calling, at the code implementation, where we have an LLM interface to external tools for processing and responding here to discover new data and integrate new, update new recent data in the response. Now, you might say, hey, you talked about this in the last video about functional tokens. Yes, but my last video was on-device, on edge devices with a very particular super agent. Now we stake here to the normal notebook implementation, to the cloud implementation. So this is here the simpler notebook. Here you have here the Python notebook, and we have some simple steps. At first, of course, we, the users, we have to define here the function that we want the system to perform. You know, function calling is what OpenAI calls it, and tool use is what Anthropic calls it. So whatever it is called, this is necessary for our specific use cases, for our specific task. I showed you how we built this, our JSON schema. Then we just have to determine the approximate function for the LLM to employ. We can train here our LLM that it chooses the right function for our task. Then, of course, we have to find here, we have to transmit here the appropriate parameters for the function within the function. Let's say for a weather app, it would be the location, and either you want it in degrees Celsius or a degree Fahrenheit, and you have a generation by the model of the final answer. Or maybe you're interested in a notebook where we do RAG from scratch. So we have our retrieval augmented generation to answer question and generate new content by leveraging external knowledge external to our primary LLM system. Here's a beautiful notebook for you, a complete implementation. And if you want to see here the steps that we take, we have the dependency, we install everything that we need. Then, of course, we need data from an external source. So we download the data. Then we have the document splitting. So this data, let's say it's an essay, is divided into smaller chunks, maybe in sentences, to facilitate here the effective information retrieval during the RAG process. Then again, as I've showed you already, we have the embedding generation. Our text embedding for each document chunk, our sentences now, are creating using, for example, Mistral embedding API, converting now the textual data into numerical vector representation in a high-dimensional mathematical space. Then those generated embeddings are stored in a vector database for similarity search and retrieval. Then, of course, we have the question embedding, step number 6, where the embeddings are also generated for my user query that I want that the system finds a solution to match the embedding space of the document chunk. Somewhere there is the answer to my query. And then, of course, similar chunks, semantic similar chunks that are close by in the mathematical vector space are retrieved from this particular vector database based here on the proximity in the vector space, for example, a cosine similarity mathematical operation, and then you generate the answer. Very simple RAG, but of course we can use here the Llama indexing, the LlamaIndex library, to make life a little bit easier if we don't build it up from scratch, but we use a little bit of help from our friends. So this process involves creating the embeddings. We index here the text chunks and setting up here a query engine for retrieval, and we use here the LlamaIndex library that we can download. Beautiful. Or if you want to do it even more professional, third solution would be build a RAG system with Haystack integration. So we utilize here the Haystack library for a more structured and framework-based approach to RAG, involving the document store, the embedders, the retrievers, and some generators for a more pipeline-driven process if you want to be a more professional. Beautiful. And for my green grasshoppers, yippee! If you're not familiar, these are the GitHub pages I would recommend you have a look at for the LlamaIndex plus Haystack here. Also, you have here the GitHub page. Beautiful. And you say, that is all nice and beautiful, but can we do more? And I say, of course, we have a beautiful notebook for you where we have now the LlamaIndex to perform complex query over multiple documents, but now we integrate something new. We integrate an agent, and we integrate here an autonomous LLM-powered agent using here specific tools. And we use here this intelligent autonomous agent. We go here for one particular version, and we go here for the ReAct agent. I have here the notebook for you, process encompass setting up the necessary computational analytical infrastructure, the parsing and the indexing of the document data, and querying this index data to answer here our beautiful questions. Now, the step that we do, the coding that we do, it has a simple logical structure. We start here with the dependency installation and the configuration of everything that we need. Then we have a connection setup, plus the data acquisition and the preparation for large PDF documents. Beautiful. Then finally, we start here with the PDF documents are parsed into text. I think in my next video, I show you here more multiple methodologies for this. We index now to create here the vector representation of each document, set up our search query, our query engines. We have a multi-step process, transform the raw textual data in a structured format to support here. Yes, yes, yes. I told you already about the vector similarity. And then it is time for our agent creation and the query processing. And our ReAct agent is created from the index data equipped with tools that describe what each engine is specialized in answering. And this agent then can process here complex questions. And the way you are familiar with this by reasoning through simpler sub-questions. So we take a real complex topic and we break it down in multiple simpler subtopics that we try to answer. And then we put the puzzle back together and we hope that we find a solution. Sometimes it's possible, sometimes it's not possible. But hey, we are here looking for how to code our agent to dynamically select here the appropriate tool so we have an intelligent agent. For my green grasshoppers here, what is a ReAct agent? What is reason and act? How do we do this here for an autonomous LLM-powered agent that is capable of interacting with and utilizing various tools that the user has to build, or you copy it from the internet to perform your specific tasks? And you have here the processing of complex query that require an understanding and integration of information from multiple sources. Well, what a surprise. Therefore, we do have here our RAG system. Action-oriented processes. So we have actions by invoking here the appropriate tool set, synthesis of information. Of course, the agents need to adapt the strategy to suit the specific requirement of the task at hand. And you have vector search technologies for efficiently retrieving relevant documentation This is a real complex topic, but we make it simple. I'll show you a code implementation of this. So at the end, you will say, hey, this is great, but you know what? It only shows you the code of integration of a LlamaIndex with a very specific LLM, beautiful for Mistral AI, for an advanced approach to information retrieval tasks where autonomous agents can intelligently navigate through vast data sets, analyze here the content that is given to them, and provide here the user with a detailed, accurate response. And you might ask, is there more? Can we do more? And of course, we have notebook number 5 for you, because we built a RAG system that is a self-reflective and a self-corrective RAG system. Are you interested? So here we go. Now, normally this would only be available to my subscriber, but you know what? If I can help you, here we go. Now, if you're not familiar here with the corrective retrieval augmented generation paper from mid of February 2024 by Google Research, here it is. And here is our beautiful notebook. And you know what? We want to have this maybe also on our local machine. So we will use Ollama, but you know, Ollama is not just for macOS, for Linux or Windows, but Ollama has also other LLMs. And for example, we have here the Mistral LLM, or you can go with Starling LLM. And please note, yesterday, our Llama LLMs were updated to version 1.1 by Google. And now we have 2 new Llama LLMs, the Llama 2 billion pre-trainable parameter and the Llama 1.17 billion model, which have a significant improvement in their performance. So with whatever LLM you go within Ollama, you know, cloud-based or on your local machine, we want to integrate now the Ollama code in our implementation. So for my green grasshoppers, I ask here GPT-4, hey, search the internet for Ollama. Is it based on the Llama C++ implementation? And GPT-4 comes back and says, yes, Ollama is indeed based on Llama C++. Yes, yes, yes. It extends here Ollama the functionality provided by Llama C++, making it more accessible and intuitive for users by adopting a Docker-like approach for pulling and running models. So this relationship allows Ollama to leverage the efficiency and the performance optimization of Llama C++, particularly its ability to run very large LLMs with a minimal setup and a state-of-the-art performance across a wide variety of hardware. And this is beautiful. And just if you're not familiar and have not seen my video on Llama C++, ChatGPT tells us, hey, Llama C++ was created by Georgy Garganov. Beautiful. And if you want to see here the GitHub site by Garganov Llama C++ to be here on the latest update 15 hours ago, or if you want to go to Ollama GitHub pages and see there the latest updates, those are the pages I would recommend to my green grasshoppers. But otherwise, how we gonna approach here the coding? It is easy. We have some simple steps, and of course we start here with the installation of all the dependencies for the corrective RAG system. And we will use here langgraph here, plus, of course, we need some API configuration. And for the web search capability of CRAG, we will use here Tavily. Now, Tavily is a search engine specifically designed for AI agent and tailored here for a RAG purpose. So this is a very beautiful code implementation. But if you have your web search utility, please exchange this to what you like, what you prefer. And then, as I told you, I want to have here the local execution support here. I want to run this on my machine using here the Ollama implementation. If you want this beautiful activated, if not, run it in the cloud as ever you like it. Now, you know we have to start with the indexing process. So we have the data loading and the processing. Then we have again the text splitting, and we have the embedding and the indexing. And here we use here now for a vector store, we use Chroma for indexing the documents in a local vector store. If you do not like Chroma, please go with any other system that you like. If you want here to go with proprietary systems that you have to pay for, please go with whatever you want, what you are familiar with, whatever thing is the best for you. This is just here a demonstration code implementation. Now the next step is here, finally we have our RAG agent here. We have our corrective RAG agent here. Beautiful. You remember from the process schema that we have here irrelevant documents sorted out by the system, and if the system says, hey, I found irrelevant documents to a particular topic, this system triggers now a supplemental additional web search. So the system goes out to a web or to another database or whatever you have defined and brings in new, hopefully relevant documents to generate the final answer by the LLM. What is nice, you can have this in a graph-based code implementation. This is where the LangGraph functionality comes in, and which allows here a very simplified modular construction of the CRAG process, or you do it by yourself, which is much nicer, through nodes representing here our function and the edges indicated or dictating here the flow between those functions. Function node state management, you know this, beautiful. And then the last step is simply the execution, and you look at the results. You have a dynamic graph that is very beautiful. You have your self-reflective correction phase, allowing the system to assess the quality of all the retrieved document. And the LLM itself decides here on corrective actions before it generates here an answer, such as rephrasing the query for another web search or directly generating an answer based on the documents that were returned and that are relevant to the query. And final step, of course, is to create here a coherent answer to our original query. Isn't that beautiful? And now the only thing is left to do, I give you here the address of all the Python notebooks, and you can go and experience this for yourself. The main source here is Mistral, the Mistral cookbook. And I think we have to thank here Sophia Yang for providing this for us. This is something very beautiful because Mistral have chosen a way that they say, hey, those are examples contributed by our community and our partners. So if you have some cool example where you can show how you integrate a Mistral LLM in a new RAG system, in a new retriever, in a new information retriever subsystem or whatever, please feel free to share them and submit this to this repo so we can publish then the code for the community. There are some guidelines and of course a disclaimer that says, hey, those examples contributed by the community and our partners do not represent, for legal reason, Mistral views or opinions. And you say, okay, I accept this. And then you go there and you have an MIT license for commercial use, modification, distribution, and of course private use. And there you have it. There you have your notebooks. And as I've shown you, 1, 2, 3, 4, and 5 are there. You download them. You have an MIT license. And you just have not just 5 notebooks, but you have 2 additional notebooks. So at the very simple step, the last notebook that is called prompting capabilities, you have here an introduction how to prompt here your LLM. Plus, I have not shown you here if you want to chat with your documents and you want to use the Haystack library. There is here notebook number 7 waiting for you to be explored. Please use those free resources. Use those things that have been provided by Code Expert. Why not stand on the shoulder of giants when you develop your code, when you develop your application? So I hope some other Python notebooks will fill up here this repo in the future. And if you have some brand new idea, if you have some new code implementation of a new methodology, and you are willing to share this with the community, I think here the Mistral AI Cookbook is a perfect place that you should check out regularly. So again, thanks to Sophia Yang, and it would be great to see you in my next video.